Every single day, specialized farming facilities across the United States raise and process over 10 million cockroaches for pharmaceutical and agricultural applications. That means in just 1 year, American cockroach farms produce more than 3.5 billion of these remarkable insects that are transforming both medicine and sustainable animal nutrition. But how does an insect that most people consider a pest become a valuable agricultural commodity worth hundreds of millions of dollars annually? Welcome to AgriCraft, where we explore the most innovative and surprising developments in modern American agriculture. Today we are venturing into one of the most fascinating and rapidly growing sectors of alternative farming that is revolutionizing both pharmaceutical manufacturing and sustainable livestock nutrition. The journey from cockroach breeding facility to medical treatment involves cutting-edge biotechnology, precision environmental controls, and processing systems that rival any traditional agricultural operation. How do farmers create optimal conditions for raising billions of insects in controlled environments? What happens inside those specialized processing plants where cockroaches are transformed into life-saving medicines and high-protein animal feeds? And why are venture capitalists investing hundreds of millions of dollars into what was once considered just a household nuisance? All will be revealed in this video. The story of commercial cockroach farming begins with traditional Chinese medicine, where certain cockroach species have been used for over 2,000 years to treat various ailments. But the transformation of this ancient practice into modern industrial agriculture represents one of the most remarkable agricultural innovations of the 21st century. What started as small-scale traditional harvesting has evolved into a sophisticated biotechnology industry that combines principles of livestock management with cutting-edge pharmaceutical research. The economic potential of cockroach farming has attracted attention from major agricultural corporations and pharmaceutical companies worldwide. The global market for insect-derived pharmaceuticals is projected to reach over $5 billion by 2030, with cockroach-derived compounds representing a significant portion of this growth. In China alone, cockroach farming has become a billion-dollar industry, with some facilities raising over 6 billion cockroaches annually in single locations. The species most commonly used in commercial farming operations is Periplaneta americana, commonly known as the American cockroach, despite its likely African origins. This species was chosen for commercial cultivation because of its large size, rapid reproduction rate, and high concentration of bioactive compounds. A single female can produce up to 800 offspring in her lifetime, making population growth exponential under optimal conditions. What makes cockroach farming so remarkable from an agricultural perspective is the incredible efficiency of protein conversion. Cockroaches can convert organic waste into high-quality protein at rates that far exceed traditional livestock. They require minimal water, produce virtually no greenhouse gas emissions, and can be raised in vertical farming systems that maximize production per square foot of facility space. The nutritional profile of farmed cockroaches rivals or exceeds many traditional protein sources. They contain all essential amino acids, are rich in vitamins B12 and B6, and provide significant amounts of iron, zinc, and other essential minerals. The protein content can reach over 70% of dry weight, making cockroaches one of the most protein-dense foods available for both human and animal consumption. Modern cockroach farming facilities represent a fascinating intersection of traditional agriculture technology and advanced biotechnology research. These operations require precise environmental controls that would be familiar to anyone working in controlled environment agriculture or pharmaceutical manufacturing. Temperature, humidity, lighting, and air quality must be maintained within narrow parameters to optimize growth rates and product quality. The cultivation process begins with breeding stock selection, where farmers choose insects with desirable characteristics such as rapid growth, high survival rates, and optimal biochemical profiles. Advanced breeding programs use genetic analysis to select for traits that improve both productivity and therapeutic compound concentrations. This selective breeding process has resulted in commercial strains that grow significantly faster and larger than their wild counterparts. The environmental requirements for cockroach farming are surprisingly sophisticated. Adult cockroaches thrive in temperatures between 80 and 85 degrees Fahrenheit, with humidity levels maintained at 60 to 70%. Lighting systems use programmable LED arrays that simulate natural day-night cycles while optimizing energy efficiency. Ventilation systems provide fresh air circulation while maintaining the stable conditions these insects require. Housing systems in commercial cockroach farms resemble high-tech livestock operations more than traditional insect farming. Multi-level racking systems maximize vertical space utilization, with each level containing specially designed containers that provide optimal living conditions for different life stages. These containers include hiding spaces, feeding areas, and egg-laying sites that mimic the insect's natural habitat preferences. The feeding programs used in cockroach farming demonstrate the incredible efficiency of these insects as waste recyclers. Cockroaches can consume virtually any organic matter, including food processing waste, agricultural byproducts, and specially formulated feeds designed to optimize growth and nutritional content. Many facilities partner with food processing companies to convert what would otherwise be waste into valuable protein production. Nutrition management in cockroach farming requires careful attention to feed quality and composition. Specialized diets are formulated to maximize protein content while ensuring optimal concentrations of bioactive compounds used in pharmaceutical applications. These feeds often include fruits, vegetables, grains, and protein supplements that are mixed and delivered through automated feeding systems. The breeding cycle management in commercial operations requires precise timing and environmental manipulation. Female cockroaches carry egg cases called oothecae that contain multiple eggs. Under optimal conditions, these eggs hatch in about 40 days, with nymphs reaching maturity in approximately 4 to 6 months. Commercial operations maintain multiple breeding populations to ensure continuous production throughout the year. Quality control in cockroach farming begins with strict biosecurity measures that prevent contamination and disease. Facilities operate under controlled access protocols similar to those used in pharmaceutical manufacturing. All feed inputs are tested for contaminants, and regular health monitoring ensures that insect populations remain healthy and productive. The harvest process in cockroach farming is carefully timed to optimize both yield and quality. Different life stages are harvested for different applications, with adult insects typically preferred for pharmaceutical processing while younger stages may be used for animal feed production. Harvesting involves specialized collection systems that minimize stress on the insects while maximizing efficiency. Modern harvesting systems use automated collection methods that can process thousands of insects per hour. These systems employ gentle vacuum collection or specialized sorting mechanisms that separate insects by size and development stage. The goal is to minimize physical damage while maintaining the biological integrity required for downstream processing. Transportation from farming facilities to processing plants requires specialized containers that maintain optimal temperature and humidity conditions. Unlike traditional livestock transportation, cockroach shipping uses climate-controlled systems that prevent mortality during transit. Processing typically occurs within 24 hours of harvest to maintain product quality. The processing stage represents where cockroach farming truly becomes an industrial operation. Processing plants employ sophisticated equipment designed specifically for insect processing, including automated washing systems, sorting machinery, and specialized drying equipment. These facilities operate under strict hygiene standards that meet or exceed those required for traditional food processing operations. Initial processing begins with thorough cleaning and sterilization procedures that remove any contaminants while preserving the beneficial compounds within the insects. Automated washing systems use filtered water and food-grade sanitizers to ensure product safety. This cleaning process is critical for both pharmaceutical and feed applications where contamination could compromise product efficacy or safety. The sorting and grading systems used in cockroach processing plants employ advanced optical recognition technology to separate insects by size, quality, and intended use. Computer vision systems can identify and remove damaged or defective insects while sorting premium specimens for pharmaceutical processing. This automated sorting ensures consistent quality while maximizing processing efficiency. For pharmaceutical applications, cockroaches undergo specialized extraction processes that concentrate the bioactive compounds responsible for their therapeutic effects. These compounds include antimicrobial peptides, growth factors, and immune system modulators that have shown promise in treating various medical conditions. The extraction process uses advanced biotechnology techniques similar to those employed in pharmaceutical manufacturing. The drying and preservation processes used in cockroach processing are critical for maintaining product stability and shelf life. Freeze-drying systems remove moisture while preserving the biological activity of therapeutic compounds. Alternative drying methods include hot air drying for feed applications and specialized preservation techniques for pharmaceutical extracts. Temperature control throughout the processing plant ensures that sensitive biological compounds remain stable and effective. Processing areas are maintained at controlled temperatures with multiple backup systems to prevent temperature fluctuations that could compromise product quality. Cold storage facilities maintain processed products until they are packaged and shipped to customers. Quality inspection procedures in cockroach processing plants rival those found in any pharmaceutical manufacturing facility. Laboratory testing confirms the concentration of active compounds, verifies absence of contaminants, and ensures that products meet strict quality standards. These tests include microbiological analysis, chemical composition verification, and bioactivity assays. The packaging systems used for processed cockroach products vary significantly depending on the intended application. Pharmaceutical-grade extracts require specialized packaging that protects sensitive compounds from light, moisture, and contamination. Animal feed products use bulk packaging systems that maintain freshness while facilitating efficient distribution. Automated packaging lines in modern processing facilities can handle multiple product types simultaneously. Nitrogen flushing systems remove oxygen that could degrade sensitive compounds, while vacuum packaging extends shelf life for premium products. All packages receive detailed labeling that includes product specifications, batch tracking information, and safety data. The distribution network for cockroach-derived products serves both domestic and international markets. Pharmaceutical companies use cockroach extracts in traditional medicine formulations and are investigating applications in modern drug development. Research institutions purchase standardized cockroach preparations for scientific studies investigating new therapeutic applications. The animal feed market represents a rapidly growing application for processed cockroaches. Poultry producers use cockroach meal as a high-protein supplement that can replace more expensive conventional protein sources. Aquaculture operations find cockroach-based feeds particularly valuable for fish and shrimp production, where high-quality protein is essential for optimal growth rates. Pet food manufacturers have also discovered the nutritional benefits of cockroach-based ingredients. Premium pet foods increasingly include cockroach meal as a novel protein source that provides excellent amino acid profiles while appealing to pet owners interested in sustainable nutrition options. The digestibility of cockroach protein exceeds that of many traditional pet food ingredients. The pharmaceutical applications of cockroach-derived compounds continue to expand as research reveals new therapeutic potential. Traditional Chinese medicine has long used cockroach preparations to treat respiratory conditions, digestive disorders, and immune system dysfunction. Modern research is investigating these compounds for applications in cancer treatment, wound healing, and antimicrobial therapy. Clinical studies have demonstrated the effectiveness of cockroach-derived compounds in treating various medical conditions. Antimicrobial peptides extracted from cockroaches show activity against antibiotic-resistant bacteria, offering potential solutions to one of modern medicine's greatest challenges. Growth factors found in cockroach tissues are being investigated for wound healing and tissue regeneration applications. The sustainability benefits of cockroach farming make it increasingly attractive to environmentally conscious agricultural investors. These insects require minimal water compared to traditional livestock, produce virtually no methane emissions, and can convert organic waste into valuable protein with remarkable efficiency. The carbon footprint of cockroach protein production is substantially lower than conventional animal agriculture. Water usage in cockroach farming is minimal compared to traditional livestock operations. While beef production requires thousands of gallons of water per pound of protein, cockroach farming uses less than 10 gallons per pound of finished product. This water efficiency makes cockroach farming particularly attractive in regions facing water scarcity or drought conditions. The waste management benefits of cockroach farming extend beyond the facilities themselves. These insects can consume food processing waste, agricultural byproducts, and other organic materials that would otherwise require disposal. This waste-to-protein conversion creates valuable circular economy opportunities that reduce environmental impact while generating revenue. Energy efficiency in modern cockroach farming facilities rivals that of the most advanced controlled environment agriculture operations. LED lighting systems, automated climate control, and optimized ventilation reduce energy consumption while maintaining optimal growing conditions. Some facilities achieve energy neutrality through solar installations and biogas generation from processing waste. Research and development in cockroach farming continues to drive innovation across multiple fronts. Genetic research aims to develop strains with enhanced therapeutic compound production, improved growth rates, and optimized nutritional profiles. Processing technology development focuses on more efficient extraction methods and improved product standardization. Automation technology is increasingly being integrated into cockroach farming operations. Robotic systems can monitor insect populations, distribute feed, and perform routine maintenance tasks with minimal human intervention. These automated systems improve efficiency while reducing labor costs and potential biosecurity risks. The regulatory environment for cockroach farming and processing continues to evolve as authorities develop frameworks for this emerging agricultural sector. Food and Drug Administration oversight ensures that products intended for human consumption meet strict safety standards, while Department of Agriculture regulations govern feed applications and interstate transportation. International trade in cockroach-derived products requires compliance with importing country regulations that vary significantly worldwide. Export certification processes verify product quality and safety while ensuring compliance with international trade requirements. These regulatory frameworks are essential for maintaining consumer confidence and facilitating market growth. The economic impact of cockroach farming extends beyond the direct production and processing operations. Supporting industries include specialized equipment manufacturing, feed production, and logistics services designed specifically for insect agriculture. This emerging sector is creating new employment opportunities in rural communities seeking agricultural diversification. Investment in cockroach farming infrastructure has attracted funding from venture capital firms, agricultural corporations, and government development programs. The combination of strong market demand, environmental benefits, and technological innovation makes this sector attractive to investors seeking exposure to sustainable agriculture opportunities. The future growth potential for cockroach farming appears substantial as markets for sustainable protein sources continue to expand. Population growth, environmental concerns, and resource constraints are driving demand for alternative protein sources that can be produced efficiently and sustainably. Technology transfer from cockroach farming research is benefiting other agricultural sectors. Environmental control systems, automated feeding technologies, and processing innovations developed for insect farming are finding applications in traditional agriculture and aquaculture operations. This cross-sector innovation accelerates technological advancement across the entire agricultural industry. Looking at the complete supply chain from breeding facility to end product, cockroach farming represents a remarkable example of how agricultural innovation can create entirely new markets while addressing important environmental and social challenges. The precision required at every stage, from environmental control through final processing, demonstrates the sophisticated technology and management practices possible in modern agricultural operations. The transformation of cockroach farming from traditional medicine harvesting to modern industrial agriculture illustrates the potential for innovative thinking to revolutionize food and medicine production. The industry's success reflects the willingness of entrepreneurs and researchers to challenge conventional assumptions about what constitutes valuable agricultural production. From those ancient traditional medicine applications to today's sophisticated biotechnology operations, the cockroach farming industry exemplifies how agricultural innovation can create sustainable solutions to modern challenges. The precision environmental controls, automated processing systems, and quality assurance protocols showcase the technological sophistication possible in alternative agricultural enterprises. The coordination between farmers, processors, and end users in the cockroach industry provides a model for other emerging agricultural sectors seeking to develop sustainable supply chains. The quality standards maintained throughout the production process ensure that products meet the stringent requirements of both pharmaceutical and feed applications, while farmers capture maximum value from their operations. Thank you for joining us on this fascinating exploration of one of agriculture's most surprising and innovative sectors. The cockroach farming industry demonstrates how creativity, technology, and entrepreneurial thinking can transform even the most unlikely organisms into valuable agricultural commodities that benefit both human health and environmental sustainability. If you found this look into alternative agriculture enlightening, Please give this video a like and subscribe to AgriCraft for more investigations into the cutting-edge innovations shaping the future of American farming. What other emerging agricultural technologies would you like us to explore? Share your thoughts in the comments and help us continue uncovering the remarkable stories of modern agricultural innovation.